Okay, last page for today. I'm going to start here. I'm going to say sketch it again. Y equals the tangent of x. You don't get good in this unless you practice it. Now, what did we find? We found that it's undefined. Tangent is undefined because tangent is y over x. And anything that makes the denominator 0 is going to be undefined. Where is x 0? It's the top and the bottom of the circle. So the pi over 2's and the 3 pi over 2's are all vertical asymptotes. So there's a pi over 2 right there. There's another pi over 2 at 3 pi over 2. Here's one at negative pi over 2. Here's one at negative 3 pi over 2. Now what happened in between? There were zeros at the 0, pi, 3 pi, 2 pi, 4 pi, negative 3 pi. There's zeros there. And then what happens? We don't need to put the ones and negative ones anymore now that we know what it looks like. What happens is in between these vertical asymptotes, it acts like a swooshy. You don't believe me? That's all right. You don't have to believe the math guy. That's fine. So I'm going to go to y equals, and I'm going to hit tangent of x. But before I hit graph, though, I better check my mode and make sure I'm doing the right thing. So I'm going to go to mode, and I'm going to change this to radians since we've been graphing in radians. And you know what? When I hit zoom, I'm not going to hit zoom 6. Look down here. I've got a zoom trig. Zoom trig will put it on this kind of graph for me. And so there's your tangent function doing exactly what we sketched. It doesn't show the vertical asymptotes because those aren't really part of the graph. The swooshies are part of the graph. They're just stuck in those dashed vertical asymptote lines. Okay, the domain. Well, we got a problem. We got a whole bunch of numbers that you can't have. In fact, if we keep going to the right and left, there's an infinite amount of vertical asymptotes here. You keep going around the circle, you'll keep hitting places where you get a vertical asymptote. So look what I'm going to write for the domain is I'm going to write what x can't be, and I'm going to take this the easiest way for you guys today. X is not allowed to be. I'm going to go dot, 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 negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, dot, dot, dot. I'm going to write it as a pattern. Every one of the pi over 2's gets a vertical asymptote. The range now, these things go on forever, up and down in between, so that's just all real numbers. So I'll do that interval style, since you guys prefer that. The y-intercept, if I put a 0 in for x, that's an angle. If I put a 0 in for x, I'm right here. And that goes y over x. 0 over 1 is 0. So the y-intercept is actually 0. There it is at the origin. The x-intercepts, well, there's an infinite amount of those too. So I'm going to do the same thing for you guys for now. I'm going to go dot, dot, dot. Let's see, negative 2 pi, negative pi, 0, pi, 2 pi, and dot, dot, dot. There is a funny way to write this. I don't feel like doing it today. I think this is enough for you guys to take in. The period of the tangent function, though. Now, this is something. Ready? Would you agree that that's one cycle? This one swooshy is one cycle because then it starts swooshing again. All of these swooshes are in between. And look where this goes from. Negative pi over 2 to positive pi over 2. Hang on. Negative pi over 2 to positive pi over 2 is only half of the circle. The tangent function is done in 180 degrees and starts over. How about that? Think about why. This goes positive, negative. This is positive, positive. We'll look over here. This is negative, positive, and this is negative, negative. When I put one over the other, y over x, I get negative, and then positive, and then negative, and then positive. It starts repeating itself after 180 degrees, right? Or start at 0 like we normally do. It goes positive and then negative, positive and then negative, positive, negative, positive, negative. So it's repeating itself after 180 degrees. This right here, that's the period. And for tangent, it is pi. The period of the tangent function is pi. That's a big deal. That's different from sine and cosine. Okay, we're going to graph 4 equations, and then that will be it for today. I want to graph 4 tangent of x. Okay, well, if you take that and multiply it by 4, it vertically stretches it, right? That's not going to move the asymptotes. It's not going to move the zeros. It's just going to make the swooshies look taller. Well, I mean, it's going to make them taller and make them look skinnier. So look, I'm going to go and I'm going to put my vertical asymptotes where they belong, negative pi over 2 and pi over 2, 3 pi over 2 and negative 3 pi over 2. I'm going to put the zeros where they belong, on all the pi's and the 0. What I'm going to do differently is I'm not going to kick this swoosh all the way out to the asymptote as quickly or even at all. I'm going to say this is so tall that it swooshes really skinny like. See what I mean? And so here I'll go, this is so tall it swooshes real skinny like. And so here is my attempt at sketching the graph of y equals 4 times the tangent of x. I know you don't believe me, so that's all right. Just go ahead and judge 4 times the tangent of x. And then I'm going to hit zoom, and once again I'm going to hit 7 for trig. And see if you don't see skinnier swooshies in the same exact place that they were before. Now, you don't believe they're skinnier, and you don't believe they have the same vertical asymptote? That's all right. That's all right. You just keep on judging. So I'm going to say tangent of x, and I'm going to graph both of them. Okay, so there's the skinny ones, and now look at the original tangent function. That's definitely wider because it's shorter. It's not that it's skinnier, it's that it's taller. There's your tangent function. Okay, y equals the tangent of x minus 2. What does minus 2 do? Moves this whole thing down 2 units. Moves it down 2 units. So that's not going to change the vertical asymptotes. So I'm going to put my vertical asymptotes at all of the pi over 2's. And I would put zeros on the x-axis, but they all got to move down 2. So this, at negative 2 pi, instead of a 0, my point will be down 2. And this point will be down 2. And this point will be down 2. And this point will be down 2. And then everything moves down 2. So this swooshy just has to swoosh a little lower. And there's the rest of it should make sense to you. Right? So there's y equals tangent of x minus 2. I'm going to take a break and we'll do the last two on the last video.